Welcome back to another video. This is going to be the first video for the new series, Detection and Response. What I'm going to do in this first video is I'm actually going to go over utilizing Wireshark, analyzing a packet. So as a security professional, right, you definitely want to make sure that you have the ability to analyze network traffic in order to learn what type of traffic is being sent to and from systems on the network that you'll be working with, right? So previously, and on another series, I talked about packet capture and analysis with a couple of different tools, not just Wireshark, Wireshark being one of them. Packet capture and analysis, right? And analyzing packets can definitely help security teams interpret and understand network communications, right? So network protocol analyzers like Wireshark that I have here, which has a GUI, a graphical user interface, can help examine packet data during the investigation or any investigation, right? Security incident. Now, since network packet data is complex, network protocol analyzers such as Wireshark or packet sniffers like Wireshark, they're designed to help any security professional pretty much find patterns and filter the data in order to focus on the network traffic that's most relevant, right? At least to the security investigation in particular. Now, what I'm going to use Wireshark to do is what most people use to do with it is inspect some packet data and apply some filters to sort through packet information efficiently, right? That's the keyword, efficient. Now, what I'm going to do, I'm going to use it to examine a sample packet capture, a file and filter the network traffic data. Now, to paint the scenario, all right, I'm a security professional, right, investigating traffic to a website. And I'm going to analyze a network packet capture file that actually contains data related to a user connected to an internet site. Now, the ability to filter network traffic using packet sniffers to gather relevant information, at least, is an essential skill as part of being a security professional, right? At least a technical one, because there's vast type of careers or certain careers you can get into as far as being a security professional like GRC or something else. Now, I have to filter the data in order to identify the source and destination IP addresses involved in this web browsing session and examine the protocols that are used when the user makes the connection to the website. And I have to filter the data in order to analyze some of the data packets to identify the type of information and sent and received by the systems that connect to each other for when the network data is captured. I'm going to do this in a few steps. Pretty much, it's not going to take too long. I'm actually talking longer than it's actually going to take me. I'm going to open the packet capture file and explore the basic Wireshark graphic user interface that I have open here, and then I'll also open a detailed view of like a single packet and explore how to examine the various protocol and data layers inside of a network packet. And a few other things, applying filters, inspecting UDP DNS traffic, and applying filters to like TCP packet data and things of that nature, right? So let's go ahead and get started. So first, I'm going to just explore the data utilizing Wireshark here. So let me actually expand that. So what I'm going to do first is open a network packet capture file that actually contains data captured from a system that made web requests to a site. So I'm going to open this data with Wireshark to get an overview of how the data is presented in the application. So let's see if it's in, I think this is it. Okay, perfect. So I have it open. That was fairly quick. I've used it. It's taken a while. But nonetheless, now I have it here. So I have an overview of a few things, right? So I have a lot of network packet traffic is listed, which is why I'll have to apply filters to find the information needed to do the additional steps I need to do, right? So this is an overview of the key property columns for listed for each packet, right? So you have the number, and I went over this in another series and other videos. The number, which is index number of the packet that's captured, that's in the packet capture file, the timestamp, right? Then we have the source, the IP address, then you have the destination IP address, then you have the protocol contained in the packet, and then the length, which is the total length of the packet, over here, and then the info, which is some information about the data in the packet or the payload, as interpreted by Wireshark at least, Now, not all the data packets, as you can see, are the same color. Coloring rules are used to like provide high-level visual cues to help quickly classify the different types of data. And since network packet captures files can contain large amounts of data, I can use coloring rules to quickly identify the data that's relevant to myself, especially when I'm attempting to abide by officially running an investigation, long story short. So the example packet lists a group of light blue, light blue packets and that all contain DNS traffic here, followed by, looks like, let's see, is that kind of greenish? Let's see. No, it's more just a purple. So I thought, nonetheless, yeah. Nonetheless, not the kind of purple packets that contain a mixture of like TCP and HTTP protocol traffic, right? So now what I'm going to do is I have this information right from the sample file. I'm just going to apply a basic Wireshark filter and inspect a particular packet. So let's go ahead and do that. Let's see. Just clicking up the screen here. Let's see. That is not how to spell. All right, perfect. Okay. Actually, should turn to another color. There it is. All right, perfect. Then should be able to actually this just a bit bigger. All right, there we go. Okay, so let's see. Cool. Make sure this is good. All right, perfect. So I have the filter applied. Sorry about that. But nonetheless, so now we see the list of two packets. I'm sorry, the list of packets, which are two different colors. Well, it looks like three different colors. Not entirely sure. I'm not sure where my mouse is highlighted. But 2 to 3 different colors, right? It's significantly reduced from what we had before, as far as the data at least. It contains only packets now where either the source or the destination IP address matches the address I entered. So now only a few packet colors, as I mentioned, like for this one, it's kind of a light pinkish, right? At least closer to pink than purple for ICMP protocol, and sort of a light green for TCP, also HTTP, which is a subset of TCP, at least as far as packets. So let's take a look at this here, right? All right, perfect. So now this opens up a pretty much a packet details pane window, right? So the upper section of the window, all right, it contains like subtrees here, where you can see a drop down where the Wireshark going to provide me with an analysis of the various parts of the network packet. So the lower section of the window contains the raw packet data displayed. Actually, let me just, well, I don't want to open all of them because we have a massive amount of data in some of them. But nonetheless, pretty much the raw packet data, right? It's displayed in like hexadecimal and ASC to text, right? And there's also a placeholder text for like fields where the character data does not apply, right? So, but nonetheless, let me see. Right. So this just provides me details about the overall network packet, right? And like including like the frame width and the arrival time of the packet. Pretty much at this level, I'm viewing information about the entire packet of data. So just want to close that back up and let's see, let's take a look at Ethernet 2. I have a couple of different additional drop down some menus here, but this mostly could just contains not as much as the frame, but just about the packet at the Ethernet level naturally, right? Including the source and destination and MAC addresses, and the type of internal protocol or IP that the Ethernet packet contains, right? So just let me close that up here and do IPv4. I see. just packet data about the data contained in the Ethernet packet, really. Like the source and destination IP addresses any IP like TCP or UDP, for example, which is carried inside the IP packet. It's like TCP here, right? And just not going to get too much into this for the TCP. I mean, just detailed view of the TCP flag set. I'm not going to get too much into that, but now I can also use, actually going to close this out here. I can also use a filter to select certain packets. So what I'm going to do is use filters, right, to specify. Let's see, actually, I'm just going to change this. Just to analyze specific network packets, right, based on where the packets came from or where they were sent to. So I'm going to explore how to select packets using either their physical MAC address on their IP address. So now that I've applied that filter, right, we see a list here that's returned with obviously a lot fewer than before as far as entry. Really contains only packets that came from this IP that I have entered here in the filter box, display box, but nonetheless. So it's only packets that will go to there. And I can also do another one. Let's see. Mhm. Something. Do one. Let's see. There we go. All right, perfect. So let me actually take a look at this particular package. So here. But nonetheless, right. So let me see. Ethernet to here. All right. So the MAC address I specified in the filter is listed looks like as the source. Let's see. Yeah, that's the source address in the expanded tree here. All right. So the protocol field in the, let's see, IPv4 subtree also indicates which IP is in the, which is TCP, which is contained in the packet, right? So nonetheless, I can move forward with using a filter to explore some DNS packets. So let's go here. Right. And let's take a look at UDP. Let's see. Let's take a look here. All right. We can see. All right. Perfect. Take a look at queries here. All right. And I see the name of the site is opensource.google.com. Okay. So that's where they're trying to go to. It looks like. Never even heard of that website, actually, now that I think about it. But yeah, so now I've located the site that we're looking to go to. So now we're just going to explore some TCP packets as well. So let's do, make sure I'm spelling it correctly. There's an issue with my P. Okay, perfect. So it looks like there's quite a few packets that were created when the user that I'm looking into accessed the web page for the open source .google.com. But let me just take a look at the first one, right? Let's see. Mm, Okay, so I was just taking a look at a few things. Want to take a look at the frame length. Looks like it's 54 bytes. Okay, and then a TTL also. All right, so let me take a look at the TTL. Actually, it's not here. '64. Okay. All right, so let me take a look at which I didn't see before the frame bits. The frame length is 54. All right, and then the header length, right? And which is about 20 bytes. Okay. Not too great. I mean, that's the name. So nonetheless, so I've gotten that. Now I've seen that data as far as the bytes. So let's take a look at now if if it works properly here. Hmm. This is the least amount. So this filters the packets containing like web requests made with the curl command and the sample packet capture file. But nonetheless, we have reached the end of the video. So I just pretty much displayed just going over different packets, different ways to analyze them, practical experience, particularly using Wireshark to do these things, opening save packet capture files, using high level packet data, if you want to call it that, and using filters to inspect detailed packet data as well. This is again the end of the video. Until the next one, stay curious, stay secure.